In this problem, I have a lens with the diameter, and it's forming an image of a satellite, and it's got these two lights that are spaced apart. And I can say that the lights can just be resolved according to the Rayleigh criterion. And I want to know the altitude of the satellite, right? So basically, there's these two lights, right? And there's a lens here, right? So it forms an image of a satellite. Converging lens. So the converging lens looks like this, right? And this light is going through here, and it's coming out, and I can just resolve those two things as being two separate things, right? Okay. So this is D, and this is L. That's how far away the lens is, right? And D is how far apart these two things are. Okay, so the equation for the Rayleigh criterion is the angle that you can resolve is equal to 1.22 times the wavelength divided by D, right? So D is like the diameter of the slit or whatever it's going through, right? So D is this distance here, basically the lens, right? So I can take this and you can solve for the angle, right? Because we know this is going to be our wavelength, right? That's our wavelength right there. And we know D is the diameter of the lens, right? That's this. That's D, right? So I can solve for theta. Theta is the angular resolution, I should say. Okay, so once we know theta, I can take this down here, and I can use the small angle approximation, right? Remember, the small angle approximation works for the small angles, right? And the small angle approximation says that if I take a triangle and I make a super, super skinny triangle that looks like this, right? Where this is some angle down here, right? That triangle looks like basically a straight line, right? But it's really a really small triangle. That basically this side over here, we'll call this L, and we'll call that D, and we'll call this H for the hypotenuse. That these two things are basically the same thing, right? We're saying that the hypotenuse of the triangle and this bottom side right here are basically the same thing, right? So that means that the small angle approximation says that theta equals D over L, right? Because this angle is so small that this divided by this will give me my angle in radians, right? That's the small angle approximation. So if I take theta, right, if theta equals D over L, and I know theta, and I know D, right, I can solve for L, right? So I can rearrange this, right, do the little trick, swap those two, L equals D over theta, and I can get L, right? And then it wants it in kilometers, right? So I can just convert from my base units to kilometers. Not that bad. Rayleigh criterion, right? We just have to solve for the angular separation here, and then take that, use the small angle approximation to figure out how far apart they are.